Right, Unit 12, Day 3. We're still solving, the whole unit is solving trig equations. The first day was graphically. We graphed them and did the second Calc 0 thing. Day 2 was the 3 tricks that we just reviewed, how to find the other angle, plus or minus for cosine, pi minus for sine, plus pi k for tangent. All of that still works. Today we're going to add factoring basically to the front end of the problem. So you have to factor first, and then everything works out just like the ones from day 2. So an example. We don't really need to, there's no theory other than factoring. So we'll do 2 examples on notes, and then we'll do 2 examples from today's assignment. So 2 sine squared of x minus sine of x minus 1 equals 0. Okay, some people can factor that right away. If you don't like, I'm going to kind of go the long way around. If you need to go the long way around, do it. It's safer. If you get to the point where you can kind of skip what I'm about to do, then by all means skip it. And when we get to the end of this problem, I'll show you what you would have skipped if you want to be a skipper. Most of you will want to be, and that's okay. But this looks ugly, so maybe if I want to clean this up, instead of looking at sines, I could look at u's. So I'm going to do a little replacement. This is very common in calculus, to do a replacement to just make your problem look a little nicer. So instead of sine squared, there'll be u squared. Instead of sine, there'll be u, and minus 1 stays the same. So the theory behind factoring is still the same. It's just maybe it's easier to factor with u's rather than sines. Okay, let's see. A is not equal to 1. This is your probably least favorite kind of factoring. Take some extra thought. Although with a 1 on the back end, it's got to be 1 and 1. And the only way to get 2u squared would be 2u and u. And then I'm going to grab a pencil because now it's guess and check time on the plus and minus stuff. So they got to be different signs to accomplish the minus 1 on the back end here. So I'll try minus 1 there and plus 1 there. Remember, this is some people call it the double smiley face. Officially, you're checking the outside and inside of FOIL to see if you get the middle term. So that's 2u minus u. Well, I did not get the middle term. My sign is backwards. I got a positive u and I'm supposed to get a negative u. That's an easy fix when that happens. You just switch the signs. So you know how to factor. A lot of thinking, a little bit of guess and check, and then you figure out what things are going on here. All right, and now is where I'm going to show the step that I talked about in warm-ups where some people are going to skip because it's like, I don't need to show that step. 2u plus 1 equals 0. U minus 1 equals 0. So u equals negative 1/2. And u equals 1. Which is not wrong, it's just not really what we wanted how to start this problem. We did this u substitution to get rid of the signs, but now it's time to bring them back. So in place of u, I'm going to put sine of x equals negative 1/2. Sine of x equals 1. Let me just finish the problem, and then I'll go back and show you how to shortcut some of this stuff if you're comfortable doing so. Now I'm down to 2 problems like we've done yesterday and you could have done before. Like this is just unit circle stuff. So sine is negative 1/2. Maybe you can do it without the pictures, but I like to see the pictures. Negative is on the down quadrants for sine. Sine is 1/2 at the over 6's. So I'm going to say negative pi over 6 and 7 pi over 6. For that half of the problem, I'm not done yet because I still also have sine of x equals 1. Let's see, sine is the y coordinate, that's the up and down. It reaches 1 when x is pi over 2.
Does it matter if the k or the pi is first?
Oh, it doesn't. I messed that up. I meant to do it the same all throughout, and I didn't do it. But it doesn't matter the order because it's multiplied.
Okay.
So 2 pi k probably makes more sense. I should probably write it that way. 2k pi seems to flow off the tongue easier, though. But it doesn't matter. I mean, you could put them in any order. So you could do pi 2k or pi k2, or you get the idea. It's a good question, though, and I should have put them all in the same order. So big picture, what happened here is factoring took us from one really complicated equation, split it into two easier equations, and then we got kind of two sets of answers. So, newsflash, all of today's problems basically are two problems in one. You got a factor to untangle the problems, and then you got to solve the two problems. Now, here's if you don't mind dealing with the signs, and you don't want to mess with the u's, well, it's going to factor the same way. So 2 sine x, sine of x, plus 1 minus 1. And so from there, many of you would say, well, that means sine of x equals negative 1/2. Sine of x equals 1. And then you're ready to answer the question. So if you can factor with sines and cosines, it does take less space, but you have to be comfortable enough dealing with sines and cosines and tangents. If it bugs you, then do the u substitution, because it is a little bit cleaner, a little bit neater. It's more writing, but it might actually go faster if you can think faster than dealing with sines and cosines. So either way, I'm completely okay. There's not like, oh, look at me, I can do it without you, or oh, I'm going to be a good student and show all my work. It's whatever works for you. There's not a better way to go. The better way is whatever helps you get the problem right is the way to go. Let's do one more. Tangent x sine x equals sine of x. Tangent x times sine of x equals sine of x. Thoughts on what we should do first to factor this guy? It's kind of like number 2 in the warm-ups. It was a long time ago, though.
Let's just have the u's equal sine x again.
You could, but before we even worry about u's, let's move sine of x over. And then yes, you could let u equal sine of x, but I think for this one I'm not going to do the u substitution thing, because I think this one's a little bit easier than that last one. What can I factor out of both of those? Looks like someone distributed something and I want to undistribute. Let's factor out the sign, the greatest common factor. And that would leave tangent of x minus, what would go in this blank? Yeah, just a 1. Sometimes people leave it off because they're like, oh, sine of x is gone. You're like, well, yeah, it's kind of gone, but I need something there so that if I multiplied it back, if I distributed it back, I'd get back to where I started. So now it's factored. We can set each of the factors equal to 0. Again, the step that you don't often show when you're dealing with easier factoring problems, but a step that might be helpful on today's worksheet. Set each of them equal to 0. And once again, the factoring has turned one really hard problem into two simple problems. let's see, so sine of 0, or sine is equal to 0 at 0, and where else? Where else is the sine equal to 0?
On pi.
Pi. And there's kind of two ways to get that answer. Hopefully you just look at the picture and think about it and get it. But if you remember the rule for finding the other answer for sine, once you have one answer, the other answer is pi minus the first answer. Still works. Pi minus 0 is pi. So 0 plus 2 pi k and pi plus 2 pi k. For that half of the problem. For the tangent part of the problem, tangent of x equals 1. Let's see, that'd be first quadrant. 1 is where y and x are equal to each other, so that's at the pi over 4. And the tangent rule for all the other answers is just plus pi k. I don't have to worry about finding another one. I mean, it'd be right there, but that's pi away, so the pi k catches everybody. So again, the back half of these problems is stuff we've already done. The front half of the problems is where we're going to run into trouble, unless you know how to factor, and then you'll be fine. So hopefully that's the case. So your assignment today is worksheet 3, but we're going to do 2 and 6 together. Kind of get us started. So grab your worksheet packet. Number 2. Okay, that looks like sort of the regular factoring type problem. Do you want me to use U substitution, or do you want me to not use U substitution? Do you need it or no? Okay, one person shook their head no, so we'll go with that. You got to decide for the whole class, Mark. Good work. So once you do a couple of them, even with the U's, you start to get the hang of it. I mean, the only way to get tangent squared is tangent and tangent, and one of them would need a 2 on it. So we're done dealing with tangents. The rest is just how to factor this thing. Switching to a pencil because guess and check. The only way to get 3 is 3 and 1, so let's just guess 3 and 1 and see what happens. Everybody's positive, so I know I'm going to be positive. Is that the right answer?
No.
Dang it, it is not, because that would be 6 tangent plus 1 tangent, so that's not it. So let's switch the 3 and the 1. Put a 1 over here and a 3 over here. Is that the right answer? It better be, because there's no other no other things to try. 2 of them plus 3 of them is 5 of them. So we got the middle term right. So 2 tangent of x plus 3 equals 0. And I'm starting to write smaller so that I can fit everything in. So tangent of x equals negative 3 halves. Right, it helps if you can do a couple algebra steps in one there. For the other one, tangent of x equals negative 1. Tangent of x equals negative 3 halves. Let's pause on that one. Tangent of x equals negative 1, that is a unit circle value. Fourth quadrant. So I can call it 7 pi over 4, or I can call it negative pi over 4. It doesn't matter, because when we do the plus k pi, or pi k, that catches all of them anyway. Okay, well that was the unit circle one. This one's not a unit circle one. Like there's no tangents that are negative 3 halves, at least not nice values. So what is it going to take to do a problem that's not on the unit circle? What's it going to take to do a problem that's not on the unit circle? A calculator. So inverse tangent, -3/2, -0.983. That's the one answer that my calculator gave me, but I need all the answers. So plus pi k. Now, a quick word on this one. Since part of this was no calculator and part of it was with calculator, like if that problem's on the test, it has to be on the calculator day of the test, because you can't answer this part without a calculator. But if you do this one with a calculator, I'm going to take off a point or two, because the directions, and they're not quite clear here, but they're going to say something like give exact values when possible. So like pi over 4 is an exact value. 0.983, that was rounded. So we could put this on we'd have to put it on the calculator day test, but we would still expect a unit circle answer for this part of the problem, rather than type that into the calculator. Number 6. Uh-oh, I don't like number 6. That's why I picked it to do. What's the problem with number 6? Okay, there's two squared terms, and they're not the same. Like if they were both cosines, we could add them or subtract them or whatever, but they're not the same. So that's kind of annoying. I can't really factor with that going on. If only there was some way to replace one of those with something. Do you remember an equation that has sine and cosine in it that would allow us to make a swap here? Sine squared plus cosine squared is 1. This one's maybe a little bit interesting because I have to decide, well, do I want to replace the cosine with something, or do I want to replace sine with something? Why should I replace cosine? That's right. That way they're all sine. If I replace sine, then I still have my cosine problem. So let's fix the cosine, and then everybody will be in terms of sine. So cosine squared is 1 minus sine squared. So in place of cosine squared, I'm going to put 1 minus sine squared. And everybody else stays the same. And now everybody's in terms of sine. So let's clean this up and hope that it factors. So -2 sine squared x, because there's two of them, plus sine x plus 1 equals 0. Some brave souls would venture to factor that, and they might even get it right. But I'm not going to be a brave soul. I'm going to be a efficient soul. What could I do to make my factoring life a whole lot easier? Or let me ask it this way, why do you not, what don't we like about that? Negative. So I can fix the negative. I can divide everybody by negative or multiply everybody by negative. And that's just going to be a whole lot easier to factor. You can do it the other way, but you just got to be super careful with the signs, with the plus and minus signs. Use substitution if you want to. I'm a little short on space, so I'm not going to use substitution. I'm going to power through with the signs. But it's not too bad. Like the only way to get sine squared is sine times sine. One of them needs a 2. It's got to be 1 and 1. I can put those in pen. And now it's just a matter of who's plus and who's minus. So +1, -1. Let's see if I guessed that one correctly. -2 and a +1. Yes, I guessed it right that time. Goodness, running out of space. So sine of x equals -1/2. Sine of x equals 1. And so again, factoring has turned one awful problem into two easy problems, or hopefully easy problems. Let's see, I'm trying to color code my answers here. So if sine of x equals -1/2, that means that x is equal to, see, sine is negative in the down quadrants, so 3 and 4. Sine's 1/2, the reference angle is over 6. So I'll do 7 pi over 6 plus 2 pi k. And what's the other one? What's the fourth quadrant over 6 angle?
It's 11 pi.
You can say 11 pi over 6. What else could you say? Negative pi over 6. Either one is okay. Also, if you get stuck and you think back to, well, wait a minute, there's a rule for sine. It's pi minus the first answer. What's pi minus 7 pi over 6? Pi minus 7/6. Let's see, 1 minus 7/6 would be -1/6 pi. So this is one of those places where the more you know, the more it sort of checks itself. You got to know one thing, but if you know 2 or 3 things, it can really help check your answer. A very common mistake on these is to stop there and think, man, I figured it out, I got it. Like, well, yes, but you don't forget about this other piece of the problem over here. Sine of x is equal to 1 up at the top, so that would be at pi over 2. And that only happens one spot. Side note, if you use the pi minus rule to come up with the other answer, what's pi minus pi over 2? Pi over 2. So that's another reason there's only one answer to that one. So, factoring today. So really, today's more about, do you remember how to factor? And then you apply that to trig equations. So factor first, splits one hard problem into two easier problems. And then hopefully you remember your trig to solve them from there. All right, that leaves 8 of them for you to do. We've still got 45 minutes or so left. Answers, at least some of them, are posted in Schoology, or they're right here if you want to check in person. So you got plenty of time to work on this. By the way, in class or on video, moving forward, we're not going to really do anything new. I'm just going to work some together with you. So, if you're really inspired, you know enough to work the rest of the packet. And nobody's going to go do that all tonight because we got another week to go. But you know everything moving forward. It's just practice, 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 practice.